Good afternoon, and good morning, everyone. I hope you can hear me fine. So thank you all for joining our webinar today. So this webinar is a continuation of our efforts that we started last year. You know, every month we host a webinar focusing on various aspects of geosteering and well placement. And basically, our objective is to, share with you and promote the geosteering culture. So before we start, let me quickly introduce our team who will be hosting this webinar today for you. Unfortunately, Joanna was not able to join due to traveling. So my name is Kirill Ronjin, and I'm a regional manager for Middle East in Roji. I'm based in Abu Dhabi, UAE, and our team here is basically focusing on providing the support to the local customers, operators, such as ADNOC, Saudi Aramco, and some other operators. And here today with me, we have Romulo Cuevas. You most probably already know Romulo from the previous webinars. So he is our senior technical analyst. He's based in Switzerland. And Romulo is doing a lot of work in Europe, in Norway, UK. And he provides a lot of training, doing a lot of technical sessions, and lead, pilot projects with our clients. So please feel free to ask questions. You're all muted, but you can type your questions in the chat or in the Q&A section. We will, try to answer all your questions either during the webinar or we just do it after we finish the presentation. So the topic of today's webinar is basically focusing on pre-job workflow. So we will discuss with you the common data that is required to build a pre-job. We will look at some workflows and basically discuss what we're trying to achieve actually with a pre-job, because this is a very important and essential step in geosteering. So it's a first and important part of the preparation, because depending on how we prepare for the job, it can impact a lot of our actual execution later. So so during the pre-job, actually, we're trying to achieve several objectives. First, we need to clearly define our well objectives. For example, do we need to, let's say, land in a certain target and stay in one target zone until TD, or maybe we want to, cross several targets and gain the necessary footage in each target, or maybe we are trying to stay close to the roof of our target zone, or another objective might be we're trying to stay away from the fluid contacts, right? So this need to be clearly identified and understood at the beginning, right, during the preparation. Then the next part is, of course, to look at the data which is available to us, to select that appropriate data, QC this data, make sure we have a good quality data, and then it's sufficient data for the job. We also built a correlation panel because we want to look at the wells that we drilled in that area where we plan to drill our lateral well. That's important because we want to see potential lateral variations, look at the log responses, and again, probably select a right tool for the job. Another thing that we need to be taking in consideration is the mapping, right, the grid. So we want to take the most updated grid, and ideally we want to look and see if we have some previously drilled wells that we already drilled and geosteered. We want to update our surfaces to make sure that we actually have the most precise grid as possible, because it will help us with the next step, which is basically well planning, right? Because we need to prepare a proper well plan, which will honor and align with our geology and our well objectives. And then we create different geosteering scenarios, and we do the so-called forward modeling. So we want to see what are expected log response we should see, right, from our gamma ray tool, density tool, and so on, because this will help us to understand and select and optimize the BHA, right, for the job, because we need to see, which tools are more fit for purpose for based on the geology. And finally, of course, we agree on the strategies. We need to, in our team, discuss and come up with some immediate action. What if, let's say, we are start cutting up stratigraphically or down, exiting through the roof or crossing the fault. So these are all part of the pre-job, and that needs to be discussed. So we'll go to next slide, please.
Yep.
Yeah. So here, as you can see, the common data set that we require as part of the pre-job. So on the left side, it's the data is related to the wells. So typically, we take the previously drilled wells in the area. We need to have trajectories. We need to have surface hole locations, logs, mud logging data, and the formation tops. And on the right, it's another geological set of data. So we typically have the structure surfaces. We can load it in different formats, like IRAP, CPS3, ZMAP, and others. We also look at the previously drilled wells, horizontal wells, because in most of the cases it helps us to identify some lessons learned. Again, look at the BHA, what worked, what didn't work, and prepare better for the job. And of course, last but not least, we bring seismic volumes, SIG-wise, and also if we have the geological model, we can bring the property volume, for example, porosity, permeability, and other things. So yeah, so this is the basic data set we typically use to build a successful pre-job model. So now we would like to show you a demo. So together with you, we will basically do a pre-job on one of the wells. And again, if you have any questions, please feel free to put it in the chat. Yeah.
Okay, thank you, Kirill. Yeah, I'm going to show you now, guys, this project. So in here, we can visualize two windows in the Geosteering, the 3D view and the map view. As you can see, we have 4 horizontal wells and 4 also type wells with 2 more pseudo-type wells. These pseudo-type wells come from the interpretation you have done before. So I'm going to show you, for instance, some of our interpretations for these horizontal wells. We have, for instance, this type of interpretation using the stratigraphic correlations and also deep picking. So it's important to have an interpretation of your horizontal well in order to understand the structural tendency of the reservoir, and then you can update your grid based on that. Okay, so I have these horizontal wells here, even some slant wells with 70 degrees. We can also geosteer that wells and to understand the structural tendency in that area, and we can populate our grids with that information too. Okay. So now I'm gonna check the. So this is the area where we are going to plan a new well. So I'm gonna visualize the logs or the correlation panel here. So I'm gonna create a correlation line in this area to understand the correlation between my logs in this area and to see where is my target zone, for instance. So I go to, I'm in the search here, I go to mode, I'm going to click here in well correlation. When I click well correlation, I can activate the new correlation line here on the left top. And then from the map view, I can just select the wells I want to include in my well correlation. It's really interactive, as you can see. So I'm just gonna take this one and this one. And when I'm okay with that, I just double click on the correlation line and the correlation panel appear. Okay, I can select also, I can activate my logs from the group tree from here. So I can see how many logs, for instance, I have 8 gamma. I just can activate it like that. And let me add 2 tracks more, for instance. I can just drag and drop here. these logs, and they automatically also appear in the rest of the wells I select here. I can also keep adding in my correlation line. As you can see, I can add, for instance, I can add this well also. So, and they will appear with the same customization I am applying here. Also, I'm going to activate my tops. Let me activate my tops, and then I can start doing like a top correlation with my. I have two, as you can see, two tight wells and three horizontal wells. Okay, the scale you are seeing, the vertical scale, we are using true horizontal length in order to get the same, like the thickness of my interpretations. Okay, that's why it's really important to start your interpretation in your horizontal well in order to visualize the logs with the true vertical thickness of your geosteering interpretation. That's one of the unique things you can do in Geosteer. You can apply this scale of true vertical thickness. For instance, if I use another scale like TVD, so I will see these logs more elongated or overlapping because it doesn't have the interpretation of the true vertical thickness in the geosteering mode. Okay, so I'm gonna use the true vertical thickness, and from here I can start doing the correlation. I can use the ghost from. I can activate the ghost in this well, for instance, like this, and I can bring my ghost to my next well, and I can, for instance, pick the top here of my top of my reservoir. In this one I don't have this, so I can bring the ghost to another area, for instance, over here. I can pick my top from here. I can even apply thickness changes inside my ghost like this. With fine correlation, I pick the top there and somewhere here. Okay, so I can also flat, for instance, the structure in the top of the reservoir. This. So yeah.
That looks like a very neat feature when you can interactively create a correlation panel by selecting the wells in the map view. So based on that correlation panel now, what do you see and what you can, I guess, suggest about our geology, about maybe potential lateral variations, thickness variations?
Yeah, exactly. So in here I can visualize like the correlation between my logs. I can see I have lateral changes from this area to the north, for instance, from the, I can say, from the southeast to the north, southwest to the northeast. Some variations in the gamma and in the I have here density and porosity logs. I can see there are thickness changes and variation inside, but actually my gamma is really flat, so I need to rely on more for my stratigraphic correlation. I need to rely more on the density and on the porosity than in the gamma that is really flat for correlations, as you can see there. And we are expecting some thickness changes also. As you can see, I can put also this again to the scale. I can reset the scale, and you can see like the structural tendency in this area is like an anticlinal. Okay, so once we are agree with the tops, we are picking. I'm going to update my grid. Why? Because always we have a grid that change, for instance, the seismic tendency, and the grid is fitted with the tops of the project. But also we need to keep updating the grid always. So I'm going to update the grid with this interpretation I have created for these 4 horizontal wells. and with the tops, I just select in my correlation panel. So to do that is quite handy in StarSteer. You go to mode, let's go to mapping, and in here in the input, I can just drag and drop interpretations and horizons and topsets and polygon, for instance. So in here, I will go to my group 3 again. I will select the interpretation. In this case, I'm using the top of my reservoir interpretation, this horizon here. And I go to my tops and also drag and drop the top of my resistivities there. I can use as an algorithm to calculate the grid. I can use convergent interpolation, which is the same of auto, and I can use as a trend the top this surface that I have from the beginning of my project, and I can use as a polygon the outline. I can use the same outline of my grid, my original grid. So I do right click on the grid to outline, and then I can just drag and drop the outline here. Once I drag and drop the outline, I need to resize the grids, the squares in here. Then once you set up these inputs, you can click create. Let's create. So the new grid appear here into the grid folder. So this is my new grid. So now this grid will shape better my interpretations, and will take in account the new tops I picked in the correlation panel. Okay, you can visualize it also here.
Yeah, that's a nice feature. We always need to make sure we update our structure. There is something that is important also when we talk about horizontal wells is so-called ellipse of uncertainty, right? So we're drilling longer wells, and due to the measurement errors, accumulation of these errors, we the TVD position of our wellbore can be uncertain, especially towards the last part of the lateral. So is there a way that we can control and maybe take into account and minimize the impact of this ellipse of uncertainty when we update our structure?
Yeah, that's quite important actually, because depends on the input you are putting in your grid. You can build a really tight and precise grid, or you can build a grid with a lot of uncertainty based on the data you are putting there. So we actually have these tools inside the mapping that help us to customize that. So we can apply, for instance, ignore after MD. So when you have a really long well, and you can get a higher ellipse of uncertainty. So you can actually reduce that just adding a certain MD that close to the landing, close to the early lateral section. Also, you can add as a constraint a vertical corridor. So sometimes you have information when you cross the layer, with your trajectory, but in some points this layer is already far away from the borehole. So you are just estimating that horizon. So when it's really far away, you can just apply a constraint and remove that data point that are really far from your borehole in here. And also you can apply influence radius, so you can affect just the area you want to affect around your grids, and you can always update the new grids here. You can once you create a grid in StarSteer, you can see what inputs were used for that grid, and also you can convert the grid into points, and then you can visualize here the data points you are using to create that grid, and then you can customize it. So actually we will have the next webinar is going to be related to mapping, so you will actually see step by step how to do all these customizations. Okay, so now, okay, I have the grid, I operate the grid, so I'm going to plan my well now, okay? So I'm going to, let me turn off this, let's bring on these polygons here, and let me activate this area. So we have some area and this area here where I can plan my well. Okay, and let me just make it bigger here so you can visualize it. So to plan a well, I'm going to use, I go to mode, and I'm going to well planning. So in well planning, I can click here, new area. So now I can just take this new area and I'm gonna put it here in this, just to shape these squares. So here. I can play with the buffer area. I'm gonna leave it like something like this, and then inside, for instance, I'm taking 6 sticks. I can put less, 5 or more. I can play with the activity succeed of these wells. So this is my horizontal wells I'm planning in this area, and with the azimuth too. And you can also manually click on them and make it larger. You can customize it inside like this. Let me make it something like this. And you can also create like an accordion shape like this. So I'm going to just explore these wells in this area, around this area here. And for instance, add another stick. So I'm going to leave it like this, and I will plan this well. I'm going to create a well plan using this direction. So it's parallel to this well here, and I'm going to explore this area, how my well and my structure looks like when I cross in this area inside my reservoir. Okay, so once you agree with that, you click here, and then these sticks go to the path folder inside the stick folder. And let me just turn off these ones here. I'm going to focus on this well here. So I'm going to go to the spreadsheet. I'm going to copy the landing point. I'm going to put it in the surface hole location. And I'm going to check a little bit here. I'm going to put my surface hole location in this area. So it's let me just update here. We are going to make this more gentle in the next release, because now it's quite manual. Yes. Okay, so this is my software location. And click OK. Once my stick is planned like that, I can convert this stick into a well. So I do right click the stick, click create well, and the well appear in the well folders. As you can see, let me activate it. And I can actually from here open the cross section of this well. So let me just make this smaller here. And let me show and remove these tracks. Okay, so this is my cross section of my new well. I can rename it. Let's put well 1, for instance. Okay, and I can treat this stick inside of my well as a target line. Okay, so I can go click on the stick, click target line, edit target line, and I can move. As you can see, we have the seismic as in the background. We have some grids also shaping the seismic there, and I have now my stick here. I can treat it like a target line. And I want to put my, let me actually use the new tops that I update, the new surface that I update, which is this one. I mean, put it like this can be also. And let me turn off this one here. So it's this one. This color is change the weight a little bit also. Okay. So this is the grid I just update, and I want to plant my well inside of this in this area, inside my top rest between the top rest and top A2 in here. So I can basically shape this target to I can change the inclination and put the target inside. I can see there is like a kind of pinch out in this area. And if I want to plan my whole trajectory with one inclination, I will be, it's going to be tough to remain inside. So I can just plan one like this, just to see in my pre-job the reaction of my dynamic logs when they exit the bottom and when they exit the top of the reservoir, how it looks like when I'm crossing this area like this. You can also change here the dog leg. Let's put 20 to make it more gentle in here to land the well. And you can always from here, for instance, if you see here, I can stay with the lateral section I'm planning here. If I move this, you can see it. Okay. So you can customize this from there. So I'm going to just leave it like this. And then we will create more plans. So I want to create just this one first, like this. Okay. So then once I'm agreed with this inclination, and you can also see in the target spreadsheet the inclination you are applying. So you are applying around 88.7 to this inclination to land the well there. Once you agree with that, you can append that inside of your trajectory. So you can customize also the MD steps you want, is the surveys MD step you want inside of your well plan, the dog leg. Okay, so I will just gonna append it there like this. So now I have, this is my well plan with this inclination. Okay, with that I can visualize how these layers or the well react while crossing these layers. So to do that, I need to link a tie well. Okay, I'm going to use this tie well, which is close by this. This is my trajectory. I have a tie well here, number 23. I'm going to use this one to use it as an example of this pre-job. You can link more tie wells if you want to see the variations there, lateral changes also. So I'm going to do, I go to mode, tie well referencing, I activate, sorry, the tie well number to this one here, linked, they turn red as when it's linked. Okay, the tie well is somewhere in this area here. And I can do now, go to Geosteering, and I can create, for instance, a dynamic log from my density. Let me change this one. Dynamic log, and also I can create a dynamic image log from this type well. Okay, let me bring this here. Track. Okay. Okay, so I can also turn on the, we have a 3D seismic, 3D models. And I can see for instance, I can highlight the porosity properties here. I can see, okay, in which area is better to drill or not to drill fast. And I'm creating, so I need to create now horizons. So I just create the plan, and they are, so the dynamic logs are not reacting based on how I cross it, because I have just 90 degrees here, as you can see in my apparent dip. So I can now go to the tie well go to the top set of my type well and do right click and create horizons from that top set. I can create top set also if I have prognosis top here. I can create top set from this prognosis top, but now I'm using the type well. So I will do right click there, horizons, and then I will use this based on grids horizon. So let me click here, and now I can just drag and drop the tops, the grids that match with my tops. This one, and this one here. The rest of the horizons are going to be parallel. If I have a top in between, for instance, if I have top here in between, the horizon will be interpolated. Okay. But this is not the case. So in this case, they will be parallel to these three grids. Okay, once I'm agree with that, I click create. So now I have now inside of my interpretation, I have horizons, and I can see now the structural tendency based on the grids. Okay, and I can see how the gamma will react and the density and the porosity they react when I enter to the reservoir and when they exit to the reservoir from the top, for instance. Then I can apply some colors here also. Let me fill it so you can see it better. Let me turn off this 3D models. So this is the top and this is the bottom. Top rest button. So you can see here when so the gamma is really high when you are above the top. When they enter is quite flat, and actually when you exit the bottom is not really you don't have too much like a drastic change. It's also quite flat too, so you don't have the gamma is not a good indicator to understand if you are crossing the bottom. Just when you cross the top, you will see a gamma peak there. And for the from the image of the density, you can see when you are crossing down or crossing up the layers, and with the gamma, sorry, with the density, you can see more fluctuation when you are inside or when you are outside. You see how the logs separate from the density and the porosity log separate when you cross the bottom, and when you enter again, they come back, they cross again. So this is a good indicator of when you are inside of the reservoir. Okay. So this is one plan. Just this is a normal plan that we always have. It's just one is a straight line with one angle. Hello. Hello.
I think yeah, I
Yeah.
think we lost you for a few seconds.
Yeah,
You can
sorry.
just-
So I was saying, like, okay, this is like a traditional plan with one inclination, and we can create a better plan now to adjust the trajectory just inside of the target zone. Okay, I can. So this is. I can create another web plan, for instance. To do that, I can come back here to my stick, okay, and I can do right click and create another well. So I can rename it as a well number 2. Okay, this is my well plan number 2. So let me activate it. So I can treat it again as this stick as target line. Okay. So I can put it here inside of the reservoir. Okay, where this is the reservoir here. And I can again customize here the dog leg. but instead of like adding all the data point now, I'm going to actually add just data from the step by step, just to build the trajectory inside of this reservoir. So I'm going to exclude the target line point and just add data till this point, for instance. So I can just append. I'm appending till this point here. Okay, and I can take this as a target line. Let me make it shorter like this. So now I can change. For instance, now we are in the horizontal section. So I'm going to put 5 dogleg just to make it more precise here. I can play with inclination, as you can see. Here. Let me append, and now I want to click this one here. Let me append. Appending here. I can also visualize it in the map view. If I turn off this one, I can see where I am appending now. So this one here. So I'm planning actually in one azimuth, okay? But for instance, if I want to change the azimuth here, if for instance the directional drill take another azimuth, I can see the reaction in my cross section and also on the seismic, how they can variate, and I can plan this well accordingly. This new structural tendency. Okay, I want to just leave it here. There. I want to keep planning this. And I can leave it till this point because here is a pinch out, for instance. Okay, can append here. So I'm using maximum dogleg 5 in area in this section. Okay, so this is my new plan. And now I can see how the logs react when I am 100% inside of this area. So I can go again to I can link again my tie well. This one linked. I can create some tops from the grids, some horizon, sorry, from the grids. And I can create the dynamic logs. Okay, so this is how it looks like when you are inside. So again, if you compare with this one, so you will see more fluctuation when you cross the bottom of your reservoir, but the gamma is still quite flat if you compare with this scenario. Also, it's really flat, and you can see maybe small layers when you are crossing the small layers inside the reservoir, small layers with different density, and the behavior of the density and porosity log. Okay, and yeah.
Yeah, that's a nice way of creating a plan step by step, so we can follow the structure and we can evaluate what is coming ahead of us, especially when we want to make a turn azimuthally. Is there a way to, for example, you expect some fault? Can you model a fault scenario and see how your log will respond?
Yes. Yes, for sure. I can, for instance, let's come back to this scenario number 1. And if I let me change make my horizons a little more transparent, so I can see, for instance, in the seismic, like, okay, my grids suggest that it's like a kind of hard inclination in this area. We have a really kind of anticlinal here, aggressive one. But it can happen that it is not an anticlinal; it's a kind of fault. We can get there. So you can just let me copy and paste this interpretation. So this is like interpretation number one, just with the structural tendency of the grids. You can quickly just copy and paste the interpretation, renaming interpretation number two, for instance. And then you can change inside let me activate it, and then I can select this area. So I need to be in Geosteering, and I can select, for instance, from here, I can select the first segment and the last one. Actually, to visualize, because when we create this automatic structural tendency based on grids, the statistics create several segments to fit all these changes. But if you want to see the overview of the apparent dip, you can click in the interpretation and apply dip averaging here, and you can see, okay, the dip tendency in each section. So I'm just taking this one, and then I can just take it from the middle and apply this foul like this. So when I'm applying a foul, I can maybe make it down here. So you will see, let me, for instance, turn off the grids so you don't see the grids in the background. So I'm just taking these horizons a little bit down based on what I can expect in this area. So if I take this a little bit down, you can see, okay, I'm going to, because I was exiting here, the base, I can enter again to the reservoir, or yeah, you can model like a different files in or different scenarios, and then you can expect this reaction in your dynamic logs. Okay, so you can create more scenarios. You can apply, for instance, thickness changes. You can, well, the thickness changes is based on the grids now, but you can also apply more thickness changes if you want. You can just go to mode and click here, thickness changes, and change the thickness, make it a little wider. So you can create your geological paleo environment perfectly here if you want. So for instance, this is the top rest. So for instance, and you can put some um, uh, patterns like this. So you can really you can really create your own paleo environment and try to fit the reservoir structure of the reservoir you have in mind, the structure of the reservoir based on the grid, the structure of the reservoir based on the seismic. And also I'm going to create another plan here quickly based on my to follow the my 3D models, for instance. I know, okay, this plan is just horizontal, like a horizontal with one inclination. This one is with more inclination, try to be inside of my reservoir. But I'm going to create another one based on my properties of the model. So again, I just do right click in the stick, creating well. So let's put well plan number three. So same process. I treat this like a target line. Okay, like this. I take it, I put it inside of the reservoir over here. Let me turn on the grids. Okay, I put it there. Okay, I'll put it somewhere here. I'm gonna also change here the dog leg. Once I'm agree with that, I can just start appending here. I click this one, append. Okay, and I can keep appending data, but like trying to aim the high permeability based on my 3D models. So you can plan your well in different ways, as you can see, structurally or actually with the properties too. You can change the color of this, so it's going to be more visible. This. Okay. Let me change here the droplet. Okay, a pen. And keep appending here and bring it a little bit up. Leave it here. Okay, now in this plan, I actually know I mean 100% like the entry of the reservoir. I mean more the properties of my 3D models, as you can see. For instance, because the top is here, yeah, it's inside, but a little bit down. For instance, if I compare with this well, this one, so I create 3 different wells. Let me put it maybe black so you can visualize it better. These two. So one is just or is following one trajectory. And the second one is following the reservoir, but just like at the reservoir. And this one is following the best properties of the reservoir. Okay. And again, you can link this to tie well reference, select the tie well, linked, create horizons from grids. Same process, drag and drop the grids here. And here. Yeah. Create. And then again, you can create the dynamic logs. And see how the reaction is when you are following the best properties with this well plan. Another important thing you can do here is quickly you can create prognosis stops. Okay, that just to finish. Yeah, extended a little more, but this is like the last part is like the analysis you can create. For instance, when you click on your interpretation, you go to interpretation format, create a prognosis stop from the intersected horizons here, and you can just quickly visualize when you're gonna enter to the reservoir in this plan, or in this plan, for instance, that you cross more layers. You can see here the prognosis stuff based on this, so you can see where you want to enter or exit the reservoir. When you enter again, exit, so you have this as a as your information to plan. For instance, if this is the plan, the actual plan, you can actually add here some comments. You can create new comments, and so you can add here based on the trajectory. Let me edit the comment. So you can take these comments and put it in like you can add some decision points here. Like, okay, if this scenario happen, I'm drilling down and the apparent dip is, is stepping up like my grids or what I'm expecting there. You can put a comment here, okay, we need to build inclination. And so build inclination with, I don't know, 91 degrees, for instance. And then you can put your your control points and your recommendations for this pre-job, because always when we are doing a pre-job as a geologist, the trajectory comes from the directional driller area. So we can just suggest some modifications, and based on our interpretation, we can suggest these new trajectories for them, so they can evaluate it and they can accept it. They can, evaluate it, and if they agree, you can use those trajectories in real time, or you can just have it as a backup. If for instance you can start another trajectory from any MD from here, for instance, and you have it as a backup. If this scenario is happening, or if the scenario of the fall is happening, you can have these trajectories as a backup to use it in real time. Yep.
Yeah, that's nice. So basically, when we create a well plan, we take into account all the available data to us. We take the type log data, we take the surfaces, the structure grids, we take the seismic tendency, and also we take the 3D model properties, so we can plan our well in the best porous zone, for example.
Exactly. Because the aim is to integrate all the data we have to understand the complexity of the reservoir. Okay, guys, if you have any question, we have like 6 minutes more.
Yeah, please post it in the chat. There are a few questions already, but I answer them related to the Starsteer version.
Okay.
So every year we release, around 3 versions with the new features based on the feedback that we get from the users. So yeah, if for example you're a Starsteer user and you are on an older version, please get in touch with us and we will send you the most recent version, so you can benefit from all these features that was Romulo was just showing to you.
Yeah. Another important point I want to highlight here. So these dynamic logs that you are creating appear inside of your interpretation folder. Okay, you have the horizons and the dynamic logs. If you want to convert it into real log, you just need to go into the dynamic log that shape this interpretation, and then you do right click, create log, and then you are creating like a real log outside of the interpretation. So inside of your well, you will see this dynamic log. It's called dynamic log because it was the name, but it's fixed. So for instance, if I move my interpretation here, nothing changed. If I move, for instance, this interpretation up and down, this dynamic log it won't react because you convert it as a real log. Then you can play with this one, or you can use Python to analyze. For instance, you can create a density porosity log from this log. You can use it here, and you can create like a density porosity log like this new track. So
yeah,
you
have
have
one question.
a lot of tools, to play
one question
and to
from Sergey. Sergey, the question is, what is the maximum degree of inclination for horizontal well is favorable for drilling process from your experience? So
yeah, well, so to change the inclination while drilling in the horizontal section, I think that the maximum dogleg allow is 5 in the majority of the cases, or the most gentle one. From there, you have less less area to play. So it's gonna be maybe 4 or 3 or even 2 of dogleg. So yeah, depends on the tools you are using. If you are using a motor, or well, and the complexity of the reservoir, for sure.
there is another question from Alejandro. Have you updated the version in order not to avoid the need of selecting the well correlation mode to create or move tops and correlation panel, as it really takes extra steps? Actually, Alejandro, the reason actually that this well correlation mode was introduced, because we notice sometimes we get this feedback that before it was very easy to accidentally shift the tops in correlation panel, and to prevent it, actually, that's why we introduced this well correlation mode. And it has the hotkey, I believe, right? If you click just W on your keyboard, you will enter this well correlation mode, and then you can operate the tops. So that is kind of a preventive, I would say, preventive way.
You can move it. So.
Yeah. So just maybe use this hotkey, right? And yeah,
it's easier.
Okay, there is another question from Gazanfar. Do you have a Python script to create isopac map from 2 grids?
Isopac map from 2 grids. It's not on the templates, but we can build it for sure. Yeah, we have our IT team that are able to build any kind of Python scripts. So yeah, we can do it, but it's not in the templates now. Also, for instance, if you know how to code, just we have a syntax, so you can understand how to call the variables to write your own script. In this case, it will be the grids, and over here you can see how to call the variables of the grids.
All right, so I think we're out of time. So again, thank you all for joining this webinar. The recording will be available also after this webinar. I believe we can post it also in YouTube on our Roji channel. And yeah, I think for those of you who are interested in presentation, we also will be able to share it with you by the email. Thank you, and please feel free to contact our team anytime. Yeah, we will be happy to support you.
Thank you very much. And remember, we have a new the next webinar in March 27 at 11 a.m. Central European Time. It's going to be focused on mapping with the star sphere.